Alright, so on the bench we have a early 50s GE portable. I like to call these lunchbox portables. This one's from the early 50s, around 1952. So what when the Beatmans came out for it, and from the information I could uncover, that's what I was privileged to. So anyway, the viewer sent this in to me, and this is a Sunday afternoon. I thought I'd be a good little project to do on a Sunday afternoon. Hopefully it's going to be a pretty simple repair. I've been out earlier today painting cars, and picked up a car from the insurance sale, and been trying to get that back together. So while that paint's drying, I thought maybe we would dig into this and see what's going on with it. Again, as I said, a viewer sent me this, and alright, so I had to go do a memory dump on this camera, of the card that's in the camera. You would think I would learn to delete some of the stuff off the camera after I make videos, but you know, old habits die hard, I guess is what they say. But anyway, so this radio here was shipped to me from a viewer, and as you can see, it's been a casualty of poor packing. And might I go ahead and add this before I even get into this, that this was absolutely not the guy's fault that sent this to me. He paid UPS at one of their retail locations to pack and ship this radio, and they did not put near enough packing material in here in the box to protect it, and you know, it got damaged in shipping. So we got a crack here, and I noticed this on the back of it too. It's also cracked on the back, and so got a little bit of a hairline right there, and right around the corner right there to where the handle rests there in that little slot. Now I informed the guy that, you know, he should probably file a claim on this radio, and you know, go ahead and get the value of the radio, but I don't think he wanted to give up the radio in lieu of the money. So I told him, I said, well, if you want me to fix it, I'll be more than happy to look at it. So, you know, of course, that's what we're going to do now. And I've got the piece that goes in here, so we'll see what we can do with that. Try and get that back together, but, you know, it's still going to be cracked no matter what. You know, you can't find parts for these things anymore, and it would just require a whole new case is what it's going to end up being, the whole front part of it, because this back cover and this front part is a completely, you know, the two different pieces. So you'd have to replace that at a minimum, and then you got damage to the back of it, so you're pretty much looking at a whole case. And you know, you just have to buy a whole another one of these model 607s to get that anyway. So anyway, getting into the radio, like I said, it's from 1952, and a neat little thing on this one here is it's got this little pop-up cover up here that's got a dial scale that's viewable from this direction, or if you have it turned in this direction, you can view it from this direction. So that's kind of neat. So anyway, I think this thing is totally dead. From what I understand, it's just dead. It's not really doing anything. So the way these things are set up, it's usually pretty much easy to find the fault, and it's probably going to be a tube filament, because this is a battery operated set as well as a wall outlet supply. With this being a battery set, it's got 1-volt tubes in it, which I found to be very easy to blow the filaments on these things. If something is not quite right in the power supply of the radio, it'll blow these tube filaments. They act as sort of like fuses in a way. But 1-volt tubes are not very hard to blow. All it's got to do is just be a slight voltage difference on them, and it'll cause them to blow. Believe me, I've been here before. So, but these tubes should be fairly easy to check. According to the schematic here, it's pin 1 and 7 on each one of them, and then we got our 3-volt power output amplifier tube, 3V4. It's a 1R5 for the oscillator and converter, and a 1T4 for the IF. Then the detector and audio amplifier is a 1U5. And then of course, as I said before, our power output is a 3V4 is the number on that tube. So I think first things first, before we condemn the power supply or anything in there, probably need to check those tube filaments and make sure we don't have an open. Alright, and with the back cover removed, the back cover comes off of the hinge, detaches from the hinges on both sides on the bottom there. We got our power cord, and it looks like some wire that was added on to the battery connections, which won't really be needed because I don't have a 67.5 volt power supply, which is most likely what this takes. The only thing I've got is a 90 volt power supply right now for the older battery operated radios. But you know, if you really needed to and this didn't have a cord, you could make a 67.5 volt, or you know, close to a 67.5 volt battery out of 9 volt batteries. But luckily we won't need to do that. Most likely this radio is going to be used on 110 anyway, so we're good to go there. So let's start pulling these tubes out, and let's ohm out the filaments and see what we get. Alright, so ohming out pin 1 and 7 on our 1R5 oscillator tube. We have about 50 ohms. That looks good. And ohming out pin 1 and 7 on our 1T4 tube. We have about 50 ohms. So that one's good. And connected to the filaments 1 and 7 on our 1U5, we have about 50 ohms as well. And connected across 1 and 7 on our 3V4, we have about 58 ohms. So we're good so far. Looks like our tube filaments are not our problem here. Alright, so I got the chassis out of the cabinet over there, and we got some work that's been done on this thing, and which I already knew about, but I've basically gone through here using the schematic and checked all the work, and everything seems to be okay. So one thing I noticed when I pulled this apart was that this speaker does not have a speaker lead on the negative part, and basically it just grounds to this basket of the speaker, which grounds here when you bolt it in, screw it in, whatever. So I put a ground lead to the back to the chassis there, so we'll have speaker sound if I need to turn it on and check it. But what I've done is I've gone through here and with the signal tracer and checked for a signal on these IF cans going through from the RF amplifier circuit, which is here, and wasn't able to get anything. So I think there's something going on with either a power issue, which is causing this stuff not to work, something like that. So I'm going to try to see if I can inject a signal and see if I can get anything. Now I know the audio circuit is somewhat working because I was able to tap here on the tube and get a little bit of a sound through the speaker. some crackling. So I believe the audio section's working. It's just the RF amp and IF stages, I believe, are not working. So I believe it's probably going to be in the RF section. That's just kind of a guess at this point. Okay, injecting a signal got absolutely nothing, so I went back to the signal tracer and just basically I'm taking the signal right out of this tuning capacitor where it goes into the tube. This tube amplifies the signal that comes out of this tuning capacitor. So basically it works like a crystal radio. I've got a really close station about a mile up the road, the transmitter, so I'm able to get stuff without really even an RF amp. So
you talk about a sex age, we're going into it now. When those little kids begin to be taught a bunch of junk, they have no right.
Okay, so we're getting a signal going into the tube. This is where it comes out. This is pin 2, where it goes into the IF can. So we're not even getting any amplification out of this tube. Now, why is that? I have a feeling it's a power issue. That tube, I did check it. It is a good tube. So I think we need to look a little further, just right here in the RF amp section. Alright, so our tube is not getting any power, and so I'm going back to the schematic trying to figure out why. And here is pin 1 and pin 7 in our now this capacitor here, I wanted to double check that and make sure it wasn't shorted or something like that, dragging the voltage down or whatever. So that looks fine, but so I'm tracing the wires off here, and we have 2 wires. We have one black wire that goes up here to the battery switch, and that works to power the filament when it's on battery power. And then we have a brown wire that goes up. I don't know if I can really show this at this angle, but there's a brown wire that runs up under here. If you can see it up under where my finger's at. It looks black in the camera, but that's a brown wire that runs up to this resistor here. This is a big resistor here. It's actually riveted to the chassis. And it has the B plus coming in from our selenium rectifier here. And by the way, this is unplugged. I won't be sticking my finger in here. So we got our wire, the little brown wire, comes over here. Okay, well, this is the main power feed for our tube filaments right here. This resistor here knocks this voltage down to a suitable voltage, because this is coming in from our selenium right here, goes through this resistor and goes into the this main power resistor, which goes over here to feed our tube filaments. Well, I have located our problem. We're going to hook a lead to both sides of this resistor. Got one here, and one here. Man, I don't know what's going on with this meter. It's going crazy. Stand by. Alright, clip lead here and probe here. This is one side of the power resistor, and this is the other side. I don't know if you can see that, but we do have an open. We're touching here, and we're getting absolutely nothing. Now, according to the schematic, that is a 2300 ohm resistor. I'm not sure what wattage these are. I'm pretty sure it's probably going to be something rather large, being a power resistor. But we have an open, and that's our problem. We're not getting any voltage to our tube filaments, so we're not getting anything lighting up. Nothing's happening. So yeah, that's why our radio's dead. Alright. Looking under the radio, I'm getting mixed up, but anyway, earlier I said this was the RF amp tube. This is the audio output tube. I wasn't getting any power to the audio output tube. So anyway, I tacked in a 5000 ohm resistor. That's all I have in this big of a power resistor. It's getting quite warm. So we're getting power through now, and I'm getting voltage to our RF amp tube, about a volt. And our IF or detector and audio tube here is only getting about a half a volt. So I'm thinking that this resistor here is probably going to be too big, so I'm probably going to have to go down some. But the problem is getting a high enough wattage resistor to do that. Alright, this is about the ugliest setup you've ever seen. You got two 10 watt 1K resistors daisy chained together to give us about, actually it reads about 2400 ohms, which is perfect. And we have reception. That's the main thing.
That's PERFORM to 79645. Start your online MBA information.
Well, when the tubes aren't getting power, they will not work. So that was our problem. Large power resistors open, so it wasn't working. But we got it working, and I believe I know what may have caused this. And I'm going to see if I can point this out. Go ahead and unplug the set, since we're dealing close to a power resistor here. This capacitor that was tacked in here, I believe probably shorted out, because these two were really, really close. And I think that may have taken it out. May have caused a short. Not real sure, but either way, there was a speaker lead here that is kind of frayed and cut, and when it comes out of the chassis here, it was sandwiched between the chassis and the speaker mounting point, and then where this case attaches was sandwiched between that, so it cut into the wire here. I don't believe that caused that problem, but you know, this is a hot lead to the speaker, and that was a concern too, that, you know, I'm all correct, and we need to get this bumble bomb out of here. These things have a tendency to explode, and we can get rid of that and replace that with a 0.47 microfarad capacitor. That's just the across the line cap. It's not super critical, but it will keep line noise out of the reception, and that needs to go. That's got to go. I'll get that replaced. But Our main thing is I've got to come up with a resistor that's going to fit in here and be able to replace that main power resistor there that's riveted into the chassis. If I can get something small enough and put it in here, we can actually use these leads here that come through as mounting points right here and right here for a new resistor, because that one's open. It's not really going to matter. But let's see if I can give you a shot of this resistor. It actually is riveted in. There's the top of it there. And it's just a large, thin power resistor. I would estimate 5 to 7 watts, something like that, that GE used. And the bad part about it is they're, you know, that style of resistor was not really available now. So we've got to come up with probably one of these ceramic deals. It'll probably end up being the best thing to put in here and replace that. So we're getting, you know, the proper dropping voltage for our tube filaments. Alright, so it's a couple of days later, and I wanted to clarify on the last video that I did what exactly we've got going on here with this power resistor, and the, you know, the one that's blown in here, and exactly what it does. This resistor supplies current to our tube filaments. And if I could point out here, this is R10, and that's our big power resistor in here. R10 supplies the main current to our tube filaments. It is a dropping resistor, and it drops the voltage from the B+, which is our main input voltage, because you have our line cord here, and it comes in and goes through the selenium rectifier, which rectifies the current from AC to DC. And then we've got this 33 ohm resistor. It goes through that, but it continues on. This is our filter capacitor here, which is a 40 microfarad. Was replaced by the owner by 47 microfarad, which is perfectly acceptable, and continues on through here to the dropping resistor. The dropping resistor drops the voltage down to an appropriate level to run our tube filaments. When this burns out, this circuit is cut off. It's isolated, and the tubes will not function because they're not, the heater circuit, which is our filaments, are not activated anymore. So it basically, this was cut off. So, you know, it goes down here through some circuits through here, but never really gets back to our tubes. So this circuit, filament circuit, which is a string like all these sort of AA5 designs have, it's cut off. So just thought I'd explain that. There's some people that actually say they learn from these videos, so, you know, I thought I would do a little explanation. There's a lot of people in here that I'm sure already knew that. But anyway, I opted to get our resistors and went with the wire wound ceramic resistor. These 10 watts are pretty large, and to save space I decided to go with a 7 watt. These resistors here run pretty cool. You know, they're warm to the touch, but definitely not as hot as our 5 watt. So I thought I'd go with a 2.2, a 7 watt. The 5 watt would probably run this, but for longevity I thought I'd go with a little bit above that with a 7 watt. This is a 2300 ohm resistor. Hardly anybody makes that value anymore, so I went down to 2.2. That does fall between you know, a 10% margin, which is pretty close. So I don't think we'll have any problem with that. Some say 20%. With low voltage tubes like this, I wouldn't go in this particular circuit. My personal preference would be about a 10% margin. You don't want to put too much voltage in these things. They blow pretty easily. So let me get this installed and see what we have. Alright, we got everything pretty much changed. I'm going to do a quick alignment on this thing, and we got first step, you're supposed to connect input lead of the input lead of the signal generator to the grid of the IT4 tube, TF3 for maximum. That was a little bit off. Alright, second step, attach a 0.05 microfarad capacitor to the grid of the IR5, which is our RF tube. Now I did this on the last one, the IT4. You got to hook a 0.05 microfarad capacitor in line with that grid of that IF, or that tube. Well, it is an IF tube, but the pin 6, which is the grid, so you're going into the tube, and that's what we've got here. But we've got to do this section and then go back is what they want you to do. So I'm going to adjust this one out and see if we get anything else out of this. Funny, you can hear that through the speaker. That's pretty good right there. Alright, next adjustment on the tuning capacitor. And that's it. Alright, and of course as soon as I turn the camera on, it's going to start oscillating. I'm going to insert this into the video. The owner of this set wanted the selenium replaced, so we went with a diode, then a dropping resistor, and then another dropping resistor to kind of get it down where we needed it to. And that setup is there. It goes down and connects in where that white heat shrink is, over by the green clip there. So been monitoring the voltage, and it's supposed to be 75 volts. That's just about perfect. It's been playing for about 30 minutes, and that's what we're getting, right at 75. So I'm happy with that. I had to take out they had a resistor in line with the selenium. It was just a 1/2 watt resistor, but since I replaced that with the diode, it's got a lot more current going through there, and I hooked a 1 watt resistor up to it, and it worked, but it was starting to get hot and it started smoking, so I knew I was going to have to go with something like a power resistor. So anyway, we got 130 ohm here and a 51 ohm there for about 180 ohms, which brings us to right at 75 volts B+. So that's exactly what we want. That's what the schematic calls for.
4545.
All right.
800-461.
Got it all back together and back playing again.
461-4545.
We repaired the crack as best as we could, or the actually broke off.
You save. Get full details.
It's there, but at least it's together. 880 out of New York is coming in pretty loud and clear.
Delivers the best internet and voice solutions for businesses. Switch to Spectrum Business today and boy, that conversation got loud. Yeah, look at that Celtics team. Doing their thing.
I've been here for a long time. Sorry about the windows. I'm getting my car so it's quiet.
Okay.
Like
that, you want the ball hit to you, want to make a great play, and usually there are plays like that, and making a clean sweep on energy supply. Heading to post-game coverage presented in part by Altice One, only at Optimum.
This is Adam Ottavino of the New York Yankees, and you're listening to the flagship station for Yankees talk, tickets, and every game. The Fan, WFAN and WFAN-FM, New York.
It's the Yankees Sunwave Gas and Power.
God is on the throne, and you get the answer to this royal telephone. Telephone to glory, oh, what joy is found. I can feel the cherubs moving on the line. Built by God the Father,
I like some good old bluegrass. I don't think I've heard that station before.
The message you just heard came from Shadow Mountain Community Church, where Dr. David Gerald.
But all you hear on AM nowadays is talk and sports. Just talk garbage.
Today morning, I go and I buy this soft drink, and I don't.
Ever offered. If you qualified, you could save thousands, even tens of.
story now.
And even helped us with the movers.
We are thrilled with our new home.
This is all just off the internal antenna. Ferrite bar antenna.
And when you use impeachment to counter.
I don't want to blast you out of your seat. Alright.
Send a donation in the mail. Right to Inside for
This is back to 880 there.
5,000.
Alright, well, got another old radio back working again. The old GE Model 607 from 1952. I believe he'll be happy with this, and hopefully it'll play for many more years to come. Thanks for watching.
Clean Energy Advocacy Group wants an investigation into whether a North Carolina legislator is violating ethics laws by doing legal work for a Duke Energy Corporation gas pipeline project while also pushing legislation the company wants. The group NC Warren filed a complaint Wednesday with the State Ethics Commission asking for an official look at the connections between the country's largest electricity company and State Senator Dan Blue, a Democrat from Raleigh. The NHL Eastern Conference Finals best-of-7 series between the Hurricanes and Bruins will begin Thursday night in Boston. After practice Tuesday, Ron Brindamore was reminded that the last time the Canes and Bruins met in the playoffs was the second round in 2009, with Carolina winning Game 7 in overtime.
That was a great series, and it's been a long time, so obviously we'd love to have the same result.
Face-off in Thursday's Game 1 is at 8 o'clock. The WPTF AccuWeather forecast, the overnight low 61, the high Thursday 82. I'm Gail Hurd in the WPTF News Center.
I'm Kilmeade Show. It begins at 9 a.m., followed by the Triangle's Afternoon News. Right here on News Radio 680 WPTF. Depend on it.